students, in this class I am going to discuss Erythro and Threo designation. Okay, so to give Erythro and Threo designation, the two conditions are very important. In that, first one is compounds which contain two adjacent chiral centers. Okay, compounds with two adjacent chiral centers only we can apply this Erythro and Threo designation. Okay, and also one more condition, at least two groups or atoms should be same or adjacent chiral carbons. Okay, at least two groups or atoms should be same or adjacent chiral carbons. Then only we can apply Erythro and Threo designation. Okay, let us see some possibilities here. In this case, in the first case, okay, so A group same, B group same. Okay, if same type of groups are same side, then we can give erythro form. Okay, we can give erythro form. Okay, here B and B same side, A and A same side. That's right. We can assign the form erythro form. Next, here B and A opposite side. That's why we can give threo form. Erythro form and here threo form. If same type of group same side, we have to give erythro form. If same type of groups opposite, then we have to give erythro form. So let us see one more possibility here. In this, B atom are same. Okay, B type groups are same. That's why they are same side. We have to assign erythro form. Erythro form. Then here B and B atom opposite side, then we have to give threo form. Okay, same type of group same side erythro form, same type of groups opposite side threo form. Here also BB same side, that's why erythro form. Here BB opposite side threo form. Okay, let us see some examples. Okay, here in this molecule OH same side and also hydrogen same side. That's why we have to assign the form erythro form. Erythro form. In this case OH opposite H opposite and adjacent chiral carbon. That's why it is threo form. Okay, threo form. Next, in this case, you see OH, hydrogen, same side. Hydrogen, same side. OH, same side. That's why you have to assign erythro form. Erythro form. Next, here you see OH, opposite. Hydrogen, opposite. That's why we have to assign threo form. Okay, threo form. Next, in this example, hydrogen. Okay, at least two atoms or groups bonded to the adjacent chiral carbon should be same side. Then we can call it as erythro form. Erythro form. Next, in this case, hydrogen opposite side. Then we can assign here threo form. Hydrogen opposite side. That's why threo form. Here hydrogen same side. That's why erythro form. Okay, here what you have to remember, very important here conditions, two adjacent chiral centers. Okay, we can apply erythro and threo designation only for compounds which have two adjacent chiral centers, and one more condition is at least two groups or atoms should be same or adjacent chiral carbons. Okay, this is two adjacent chiral carbons. At least two groups should be same on these adjacent chiral carbons. Then only we can apply erythro and threo designation. Okay.